that there are multiple realities involved in our universe. And they're all interrelated, but they're interrelated by being phased out of our reference, phased out in time by at least 90 degrees into another reality.
All right. Al, would that be, again, staying with the analogy of the slinky then, would that be instead of traveling along the surface of the slinky and going around and around and around and around, it is as though you're jumping from one link to the other link directly without traveling the entire path? That
is correct.
All right.
Now that you can again look at that in terms of another analogy, quantum physics, which the modern analysis using quanta is not only have quanta of energy and quanta of matter, you have quanta of time according to that theory. And it is in a discrete little jump, as it were, which fits quite well the sleazy model. What we were attempting to do, and did eventually do, was to take an object, create a field around it, and move it in relation to the reality which we normally exist in, move it part way out. And if you get far enough along that edge, the sleazy, so to speak, what happens is the electromagnetic energy called light and also radio waves, particularly the higher frequencies that we use for radar, no longer are reflected by the object. And if they pass straight through it or around it, you can do it either way. There is no energy reflected. The object is invisible because it requires a return of some kind of energy so that you know that the object is there.
But not invisible necessarily at that point to the eye?
Yes, invisible to the eye also.
Oh, okay, so gone.
Gone so far as you can see. And that was what they did in 1940 at the Brooklyn Navy Yard. They made the object invisible to eye, to a camera, and also at that time it would have been invisible to radar, but radar was not of a major development yet in 1940, even though the Navy had been working on radar systems in 1938 and had some on board ship, experimental. By 1943, of course, radar was well developed. We had excellent radar. The Germans did, the Russians did,
right,
and so forth.
All right. Again, what I want to understand is technically how this is done. In other words, what actual process do you use on an object?
All right. The basic theory which was developed at that time, partly in accordance with Einstein's unified field theory, which does exist and is alive and well, and is never in the status of being incomplete. It was stated that way to the public and was completed about 1938 and given to the government, and we had access to it at the Institute. So all of that says, to make it simple, or try to make it simple, is that all of the elements of our universe, the energies which we normally consider, the electric field, the magnetic field, the gravitic field, if you will, which it is a field, are all interrelated in such a manner that you have a fourth element which is also locked into them, and that is time. If you manipulate any three of those, you can affect the fourth. Right. In this case, the one we wanted to affect was time.
Right.
So if you know how to interact between the electric field, the magnetic field, and the gravitic field, you can affect time. And that, of course, refers to a limited area in which you can affect those three fields.
Through what means?
Basically, electromagnetic manipulations. In terms also of certain mathematical constants which relate to the Earth's constants. And one of the main constants here on Earth, which was used to generate and to predict window frequencies for certain phenomena, is the mathematical function of pi over 2. That is one of the keys. 1/2 pi, if you will. Multiples thereof. I won't go into that as a long mathematical dissertation, but basically any frequency involved, which is pi over 2, is active in a special sense. What they were doing was generating an electric field through means of a radio transmitter, which generates an enormous electric field from an antenna, depending on the power level.
Well, an RF field, do you know at what...
Yes, an RF field, basically.
Do you know...
Electric component.
Yeah, okay, Al, at what frequency was this radio frequency?
Radio frequency was operating basically at 160 megahertz, but it was modulated. The earlier system developed by Tesla for the first test was what they call an analog system, fully on but modulated with special frequencies. But it had more than a RF field or electric field component. It also had magnetic fields, where you had a rotating magnetic field as well as a rotating electric field.
All right, you're ahead of me a little bit. 160 megahertz, that's typically where the police and the fire departments are very close to where they operate. Today, that's right.
Back in 1942, 43,
that was a
cutting edge of technology.
Absolutely.
That was the frequency the radar systems operated at in those days.
All right. I think that's right. As a matter of fact, it's right. And then they moved up into the 400 megahertz.
That's right, after the war.
All right. So you've got radio frequency at 160 megahertz. Do you know what mode of transmission it was? AM, FM, pulse?
There was AM in the first system, pulsed in the second system developed by John von Neumann. I'll have to go into the history of that, how that came about. But in any case, they were using AM with 4 levels of modulation. And it was a quadrophase transmission system, i.e. there were 4 antennas designed so that they would produce a rotating field with 4 lobes. And they rotated counterclockwise, and there was a special modulation on it. And that, in the initial system, was 4 transmitters at 500 kW each.
500 kW? 500,000 watts?
That's right.
Wow.
That is not for the initial test in 1940, but for what was designed for the Eldridge.
That's a lot of power.
That's a lot of power. And you had 4 coils on the deck of the ship, which were specially designed Tesla coils, designed by Tesla, primary only, which was a conical shape. It was narrow at the top and much broader at the base. It was hollow copper tubing, water-cooled. It was about 1.5 inches in diameter, and it was pumped from both, direct connected to the generators, which were below deck. There were 2 major generators, 75 kVA each, and there were 4 outputs, 2 from each generator. They had to be very carefully phased also to produce a rotating magnetic field within the electric field.
All right, so these were producing the magnetic element.
That is correct.
4 of them.
Correct. Now, the 2 of those interacting together at a certain rate and ratio will affect the gravitic field, particularly if you have enough power, and that's one of the reasons they wanted enough power for this. The mathematics of this are still buried and classified, and I do not, at this point, recall what the math was, because certain other things happened to me, which I will go into as I develop the story. But that was basically the system that we were using. It affected the gravitic field, and the 3 of them would produce essentially a rotating field, which was looking, if you wanted to take a plane view of it, look down on it, looked like a donut. And the ship was in the hole, if you will.
I understand. I guess what I want to understand now is, so you've got 4 devices creating a magnetic field.
Right.
And you've got 4 antennae creating an RF field at 160 megahertz, and all of this somehow interacting. Were the magnetic fields also in rotation, or were they constant?
No, they were rotating also. One inside the other at a different rate of speed. Actually, one was rotating at twice the speed of the other, but both rotating counterclockwise.
Wow. All right, RF. You've got RF, you've got the magnetic element. Was there anything else, or was it just those 2 elements together?
It was those 2 elements together. There was nothing else directly involved other than the fact, of course, the fields being generated had the lower half truncated by the seawater, because seawater is the most excellent absorber of both RF energy and magnetic energy. Magnetic fields do not propagate well through seawater. They do, but they're attenuated rather rapidly. In any case, that was the basic idea. I'll not attempt to go into any mathematics on this.
Do you know offhand how much power was directed toward the magnetic fields? We know in the case of the RF it was 500 kilowatts per.
It was about 150 kVA total.
All right.
They were looking at each coil, they were looking at about 37.5 kilowatts kVA, round figure.
Okay.
You can't say kilowatts because that refers to DC. kVA is AC with what the phase angles or power factor may be involved.
All right. At this point, Tesla was involved in the experiment, correct?
That is correct. He was the first director, and he remained a director through this period of time. Now, let me go into